All right. 30, which one? 33? All right. All right. Quiet, please. 33. To take the derivative of z, quiet, please. This one is different than what you're thinking of as far as a squared. The squared goes with the 2z plus 1, not with the secant, because of where it's written. So you have actually an extra set of parentheses around the squared. Don't confuse that with secant squared of 2z plus 1. That means the squared goes with the secant also. And it is different. So wherever the squared is, this one is just for the angle, not for the secant. So it makes it a little bit easier to take the derivative of. So we're not going to do this one. Hey, how you doing? So the derivative of secant is secant tangent. And then we'll take the derivative of the angle. The angle is going to be 2 times 2z plus 1 to the first times 2. And remember, we take the chain rule. We take the derivative of the outside function. The angle stays the same. So this is still 2z plus 1 squared, and this is still 2z plus 1 squared. So the angle didn't change. Yes? Oh, the first two comes from the exponent, and this one comes from the coefficient of the variable. The derivative of 2z plus 1 is 2. Okay?
So it's like 2 steps.
Exactly. Because there's an outside function of secant, then a squared, then a linear function 2z plus 1. There are 3 things to account for when we're taking the derivative. So, all in all, you can take the 4, put it out in front here with the 2z plus 1 times secant 2z plus 1 squared tangent 2z plus 1 squared. I think I'm going to change the quiz. I just thought of a better question to ask on number.
No, that's
Tomorrow I'll preview the quiz, or today if I have time.
I wish we had like studies.
That's what we're doing. We're studying by doing these problems. Yes, studying. You move your pencil. Great! You get that one right? Okay. Yep. Should what? Is this close to being right?
Yes, that's right.
Oh, if I have to take the derivative of something squared, I'm going to have 2 times something to the first. And it just so happened the derivative of the inside was also 2. Okay? Remember, the derivative of any linear function is just going to be the slope of the line. Have we go? Sure. 25? Sure. 25. All right, quiet please. 25. I would simplify first because there's a single term with a denominator. Now, single term with a denominator, I can simplify by subtracting all the exponents that have the same base of w. Why? I avoid the quotient rule. I avoid simplifying. I can rewrite the function as g of w equals w to the 2 minus 3 halves minus 4w, 1 minus 3 halves, and then plus 3w to negative 3 halves. I can break it into 3 individual pieces, and then I can take the derivative of each one, and then I can simplify it to get my final answer. So this is g of w, which equals w to the 1 half minus 4w to negative 1 half plus 3w to negative 3 halves. And then the only thing you have to left to do is to factor and rewrite it and you're done. Which term are you going to factor out? Obviously, it's going to have a w in it. To which exponent? Yeah, negative 3 halves. You always take the smallest factor. And negative 3 halves is much smaller than negative 1 half, much smaller than 1 half. The question is, what do you have left after you factor out the negative 3 halves? What's a half minus a negative 3 halves? 4 halves, which is 2. What's negative 1 half minus a negative 3 halves? Close. 2 halves, I believe. Minus 4w plus 3. So then we have g of w. You have w squared minus 4w plus 3 over w to the 3 halves. Yep.
Why did we just go back?
Oh, we never took the derivative.
Yeah, we never took it.
Nice. I was all excited about simplifying. Yeah, I know. That's great. No. It was for fun. G prime of w equals w to the 1 half, 4w to the negative 1 half. Now I got to take the derivative. Phew. I was trying to take my step by step, not to lose anybody, but I forgot to take the derivative. Negative 3 halves plus 3, negative 3 halves, w negative 5 halves. There, that looks a little bit better. Well, now I'll factor, since I already did it once, should be kind of easy. I'll take a half out. And I'll take a w to the negative 5 halves out with it. So that'll give me w squared in the first term on it. Bless you. Negative 1 half minus negative 5 halves will be 4 halves w squared. The negatives are still there, so that'll be a plus. There's a 4. Negative 3 halves plus 5 halves, since I'm subtracting negative. So it'll be just w to the first. And then minus 9. I factored a half out, I think. So, as I did on the last incorrect step, this one factors kind of nice, actually. How's that? That looks better. Because I have a half. Okay. All right, last one. Which one? Oh, Abigail? I got to do 19 and I'll do 27. 19. Did you simplify it first, or did you just take the derivative? Derivative? G prime of z. Sorry. 2z minus. Now, how are you guys, are you using the reciprocal rule or the power rule when it comes to? All right, so you're thinking of this 1 over z squared as z to the negative 2?
Yeah.
All right, so then that would be a plus 2z negative 3. G prime of z. Factor the 2 out, so I have a 12. Z squared minus 1 over z squared to the 5th times z plus 1 over z cubed. Now, do you want to get a common denominator with the last one or just leave it? Well, that's what they have. Okay. We'll just leave it then. Yeah.
Yeah.
Sorry? Z plus 1 over z cubed. Does Chase ever listen to these videos when I make them? I'm sure he does. Yeah, he does. He's got mono. All right. He does. Which one now? 27? Oh, boy. And this one will be the quotient rule. This will about finish off the day. Over 4x squared plus 9. At least nobody in the room would make the mistake of calling that 2x plus 3. That's a good thing. Whew. Then they'd say, oh, it's 1, derivative of 1 is 0. Remember, you can't put the square root over the plus sign. So we have to use the quotient rule. Rachel? Product rule? Yeah, except too many people in here forget the plus sign. What are you doing with your pencil? Yeah, you crossed the aisle with your pencil. Yeah, don't do that again. No, don't cross the aisle. H. Nope. Don't cross the aisle. Oh, minus. Sorry. 2x plus 3. All over the denominator squared. Quiet, please. Let me look at this. The derivative of the numerator is 2 times the denominator minus the numerator times the derivative of the denominator. Is that close? Should be. Oh, factor. I can factor out, since I have the same base, a negative a half. I can also factor out a 2, can't I? H prime of x. So I'll factor out the 2. I'll factor out the 4x squared plus 9 to negative 1 half. Leaving me with a 4x plus 9 to the first and the first term minus a 2x plus 3. A half of 8x is 4x, but I took a 2 out, leaving me with a 2x. All over 4x squared plus 9. The quotient rule is, no, I'm just underlining the exponents. Yeah, after you move this term down to the denominator, put the 2 right there. 4x squared. Yes?
Do you use the general when it's like something plus something to the something not 1?
Right. 4x squared minus 4x squared plus 9 minus 6x all over 4x squared plus 9 to the 3 halves. So the 4x squareds drop. Nice. Nah, we probably wouldn't. I just leave that as your final answer. Woo, that was fun. What? Factor out 3? I could. I think I've had enough fun. No, we're not done for that. We're just getting started. I love that. They both looked at the clock at the same time. Stephanie and Kaylee. It was like, are you kidding me? I have plenty of time. No, we are not. Everybody in the room knows the schedule for the week, and we have a monster quiz on Wednesday. 10 questions. You have 42 minutes for 10 questions. If you have homeroom, want to start earlier, fine by me.
What's it over?
3-1 to 3-6. I know. Some of you still need to practice because you did the limit definition of a polynomial. On your test on Wednesday, there'll be the first question, number 1. Use the limit definition, find the derivative of, and it'll be a trig function. I'm sure you've all been practicing that because I told you it was going to be on there. What? Wednesday. Yeah, you got plenty of evenings. Yeah, JV games cancel night, so you can study.
What, JV game?
Yeah, you can study. Yeah, homecoming week. Powder Puff. Yeah, I love that. Sure. I'll be there. Save me a seat up in the grandstands. I'll say hi. We're still going to start the notes.
Yeah, me and Hannah will study in the bleachers.
Yeah, 3.6. Today and tomorrow. So when I go over the plan for the week and it says 3.6 Monday, 3.6 Tuesday, and I go over 3.6, that doesn't mean anything?
We're on 42.
Excellent. We did that one. 42. Grizz, what would you do first, besides writing it down and pay attention?
I'm helping Hannah.
Nice, throw it under the bus. Now go forward, drive over again, and answer my question. You can't, it's your question. You have to, all you have to do is insert the blank. To take the derivative of g of s, the first thing you use is the blank rule. No. It is the product rule. I saw 2 of my former calculus students Friday night's football game. I had how calculus was going. Actually, they didn't. Because they were too upset about the football game. Had they, I would remind them how good they were at the product rule. As soon as I saw these 2, I was thinking product rule. So, what's the derivative of the first function, Miss Graham? Very good. What is the derivative? Did you write that down?
Yeah.
This is called studying for the quiz. Did you work ahead? You need to take the derivative of cosecant for the next term. What's the derivative of cosecant? Negative cosecant cotangent or negative cotangent cosecant? Nice. And the angle doesn't change until you take the derivative of the inside function. So you end up with negative cosecant s squared cotangent s squared times the derivative of the inside, which is 2s. Nicely done. I know, it makes it hard. That's why I use parentheses. The only thing you have to do is factor out the cosecant of s squared, and you're pretty much done. Well, you don't have to factor it out if you don't want to. You can just put minus 2s squared. You know, either way is fine. There's not much to simplify on this one. Like I said, you can either factor it out or multiply it out, and you'd be done with it. That's what you'd be expected to do on Wednesday. Okay? Then you can leave it like that, or you can factor it out. Makes no difference to me. That should be a multiplication sign if you're going to factor it out, though. I hate copying and pasting like that. There we go. You can either factor it out and multiply it, or you can leave it. Either way. But you're going to start solving these for 0 in the next chapter. Do you remember how to do the differentials to approximate the square root of 37? You have to use square root of 36. Very good. Those are some things that are going to be on your quiz on Wednesday. Do you remember how to use the limit definition? Take the derivative of sine.
Yes, I do.
Good. How about cosine? How about tangent? Tangent's not. It's different. All right. Ready to move on? Moving on. You ready to move on? Where's your pencil? Where's your pencil? Perfect! Uh-oh, it's stuck.
Hard. Can we not do it?
Oh, that would be fun, wouldn't it? I want credit, but I don't want to do anything for it. All right. Sine 4v, cosecant 4v. A little grumpy. Nope. All right. Wrong-o, bucko. I did. I'm not. No, I said some people are. Close? Let's all think like Stephanie Canfield. She's going to give us the answer in just a moment. Michelle's going to throw the answer. No!
You do the chain in the
That is, you should not have forgotten your trig. Simplify. Sine times cosecant is what? 1. What's the derivative of 1? Moving on. That was easy.
How is it?
Because cosecant is 1 over sine. Nice. Nice job, Michelle. You would have. You would have to simplify it all the way down to 0. Yeah, it would simplify it all the way down. It would. Stephanie, keep your hands to yourself. I know, she's all excited. Just leave her be. Ready? Try this one.
Is it 1?
No.
Is it 0?
No. Wait a minute. I'm thinking of a different way I could have done this.
This one?
Mm-hmm.
You started
I could have sledged it out. I could have sledged it out, but I didn't. I didn't simplify it because it wouldn't get rid of the denominator. Can you what? Wednesday note card? I don't know, because on the exam you can't. Focus is your problem.
Yes.
Focus. Secant of 2x divided by 1 plus tangent of 2x. Like I said, you could have sledged it out, or you could just take the derivative and go with the product rule, or quotient rule, sorry. Kaylee, what's the derivative of secant of 2x? It's just tangent of 2x. What did you say? Times? Right. Tangent of 2x times secant of 2x times the derivative of the inside, which is, right, times 2. So, secant of 2x, tangent of 2x times 2. And then in the quotient rule, do you add or subtract in the numerator? You subtract. What's the derivative of 1 plus tangent of 2x? Derivative of 1 is 0. The derivative of tangent of 2x is secant squared of 2x times 2. The secant squared 2x is the derivative of tangent, and the 2 is the derivative of 2x. Because when you take the derivative in the numerator, this first expression is the derivative of secant. This 2 is the derivative of 2x. Likewise, back here, the secant squared is the derivative of tangent of u, and the 2 is the derivative of 2x. Okay? So you have two parts. Remember, the chain rule... Turn around, Emily. You're going to miss something. Anyway, all you have to do now is factor and you're done. It's not that difficult. Maybe combine like terms, whatever. How's everything going with this one? The trig ones always look rough, but they're easy to simplify. Just take out a secant of 2x along with a 2. And you're pretty close to done. A couple more steps, that's it. Take out a 2. Take out a secant of 2x. It looks like here I just kind of multiplied it out first. Not really. It's just still going to be the same thing. Take out a 2 secant of 2x, and that's about it. You're done. It looks a lot more difficult than it really is. The algebra isn't that difficult because you're just factoring to get, work down to a nice term. The hard part's going to be coming when you solve it. Yes? Oh, you mean how I was thinking about before? I was thinking that secant, I think Alex had the same thought. This is 1 over cosine of 2x. Oh, sorry. And then tangent would be 1 plus sine 2x over cosine 2x. Then I thought, oh, I could have multiplied by cosine 2x in the numerator and denominator, and that would have went. This would have went. So I had 1 over cosine of 2x plus sine 2x, which would have been considerably easier to do the problem. That's the way I should have done it, but I didn't see that until it popped up there. I was like, oh yeah, secant and tangent. Both have denominators of cosine, could have sledged it out and got down to the cosine and the sine. Yes?
What is the last term?
It was cubed, so I made it squared. It came cubed because I had to multiply those two together. Okay? I just want you to know. Fine. Good. Did it taste good? Oh, okay. So it doesn't taste good. Oh, it looks like you're taking. Sorry? I didn't take it out until after I multiplied it. I multiplied it first. I got the secant cubed. Then I factored out a secant, not a secant squared. So I factored this secant out, and I factored out that secant, and I factored out a secant here. Oh, I see. This too? Yeah, probably. Yeah. I think I meant the squared. Yeah, it should have been out. Sorry. Ready to try another one? I am. No, we're not even to the fun ones yet. Yes. How? Trust me.
There's a bunch of words.
How do you make a word problem out of it? What are their words?
Hey, like this. Ready?
No, I don't want to.
It's fine. Find the equations of the tangent line of the normal. First of all, we'll just do the tangent line of this equation at that point. You've been finding the equation of a line all year. And this one, the only difference is to take the derivative, you have to use the chain rule. And then after this, we will find, the point slope formula to get our answer. Should be quite easy. Is this point on or off the curve? How do you know?
It's on.
You put the negative 1 in the square, you get 1 times 2 plus 1 is 3. It's on. Life's good. What's the derivative? Matthew?
1/2.
Keep going. Right? Perfect. Yeah, times the derivative of the inside.
Oh.
Very good, times 4x. And that gives me the slope of which line, the normal or the tangent? Tangent. So you put in -1 for all that, you just get the slope of the tangent line. Not that difficult, especially if you do the point slope formula for the equation of your line.
So you just put in x.
Yeah, you just put in the x value, put in that, and you come up with negative 2 root 3. That's the slope of the tangent line. I talk slow because that question is going to be asked numerous times on Wednesday. Find the slope of the tangent line. You put the x value into the derivative to find the slope of the tangent line. So, nicely done. I'm not sure what's going to happen next. I think I'm out of room, so I'm going to go to another slide, I believe. Slope. So to find the equation, I would take y minus the point equals the slope times x minus the point, and then you're done. A lot of fingernail issues today. I did the y minus y1 equals m times x minus x1. We did that last week? Okay. How do you find the equation of the normal line? Change the slope to what? That's negative 2 over root 3. What's the equation of the normal line going to be? Root 3 over 2. How do they know that? Well, easy. The opposite would be positive, and the reciprocal, you just flip the numerator and denominator. That's your answer. I don't think that was quite worth all the fuss it was made out to be. Oh, can we take a day off, please? 2 steps. It is. No. That's still A, normal line. Well, there is. What about B? What are you going to do with the derivative? Set the derivative equals 0 and solve. That doesn't look too difficult. So if you set the derivative equal where the tangent line is horizontal, what value is going to make that derivative equal to 0? I call on the expert analysis of Kylie Stewart. Yeah. That's it. X is 0. Problem solved. That's for B. It says find all the x coordinate where it's equal to 0. You had plenty of practice in solving equations set equal to 0. You've used a calculator. What's wrong?
We didn't have a 66. Oh, no, I'm on the wrong track.
That's okay. Never mind.
I don't know where I am.
There are 92 problems. 5 minutes. Should I stop here? Or should I hit the clicker? Oh!
Wait, that's the second
These are
value.
way too many problems.
That's just no, chain rule.
Right, it's a chain rule.
That's easy.
Right, you just do it not once, but twice. Yeah.
Is that necessarily mean you have to use the chain rule for the second part?
Well, actually, you just take the derivative of the answer. Is all you do. So if the answer needs a chain rule in it, it does. If it doesn't, then you're fine.
Let's do it.
Wait a minute. No, I think I'm going to stop it. I think I'm going to preview your quiz.
So we're not doing
Well, I think I'm going to better preview your quiz because some of you are going to freak out on Wednesday. I would get here early or I'd come in homeroom and start. You're going to write this on a separate sheet of paper because all 10 questions are on the front. Do you see Grizz? Her eyes almost went cross.
I tried to read them.
Yeah! I'll save you the trouble. I'll read it to you. Use the given function to answer question 1 and 2.
What'd you say?
Use the given function to answer the questions in 1 and 2. In show, Chase doesn't even know about this because he's not here. He's got mono.